Hello and welcome to EVPN. For those who don't know, that's Entertainment Video Game Programming Network, and I'm here to review a video game almost as famously known as Mario, Portal. Portal was released in 2007. Portal is a first-person puzzle platform video game developed by Valve Corporation. In today's review, we will be reviewing the realism of Portal by testing its world-renowned physics and see how realistic it really is. To test the realism of Portal, I will test its acceleration, the gravity, by dropping a weighted storage cube from different heights and time it to find the acceleration in Portal. Then I will test the realism of movement by a series of tests on running, walking, jumping, and analyze the results. Finally, I will test the projectile motion of the weighted storage cube by putting a portal on the wall and see if the initial and vertical velocities are the same throughout each trial. In order to calculate anything, we must first know the dimensions of objects in the game, such as the weighted storage cube, the height of a wall panel, and the length of a tile. As seen in the picture, the height of a doorway is 7 feet, which means the height of one wall panel is also 7 feet. And the dimensions of a cube is 2.3 feet, and the dimensions of a tile is 1.75 feet. To test the realism of a free-falling object in Portal, a weighted storage cube is dropped at 3 different heights and is then timed. The cube is dropped at a height of 14 feet, 21 feet, and 28 feet. The recorded time for the drop at 14 feet was 0.86 seconds, and for the second drop at 21 feet, it was 1.13 seconds, and for the third drop at 28 feet, it was 1.58 seconds. The slope of the graph is 5.81 and the acceleration would be 11.62 meters per second squared, which is decently close to gravity's negative 9.8 meters per second squared, resulting in a realistic rating of 8 out of 10. The second test of realism is to test the realistic movement of a character in the game. In order to do so, I had a friend of mine go through a series of tests such as jumping, jumping forward, running, running and jumping and turning in the air, and simply walking back and forth. Each individual test will be graded out of 10 for a realistic rating. So for the first test of walking back and forth, sadly due to poor connection, there was a lot of lag. Ignoring the lag though, the movement of walking was realistic right down to the individual movement of the joints, earning the walking back and forth a strong 10 out of 10. For the test of jumping, the animation for jumping is a bit odd due to the fact that while the character moves its legs in the air, but the movement of the jump is realistic. It's clear that the character's acceleration slows down at the max height and speeds up as it gets closer to the ground, earning jumping a 9 out of 10. The running and jumping is realistic. The movement of the jump is the same from the beginning to max point and the same from max point until it returns to the ground, earning running and jumping a 10 out of 10. I would personally say that this running and jumping and turning is slightly unrealistic. The video game turning and jumping looks to be too smooth. Especially immediately after the landing, the robot was able to start walking backwards immediately, something I wasn't able to do. Maybe that's because I'm just a mediocre human being though. The turning while in the jump was realistic though due to how it seems the character slows down while turning, something I did as well. I wanted to compare running and trying to turn in the air to a real-life scenario, so I decided to do it myself. And as you can see, I struggle because my momentum seems to bring me backwards and makes me lose my balance after I land the jump, something that the robot does not do in Portal, resulting in a realistic rating of 6 out of 10. For the last test, we will see if the initial horizontal velocity is constant throughout the game, as it should be, because due to the cube's gravity, which is then used to project the object forward. The cube was projected from 4 different heights and then timed. By using the dimensions in the room, such as the tiles and the floor, I was able to find the change of x and then solve for the initial horizontal velocity. I started off by putting a portal on the 7-foot wall panel, but the cube is really projected at 3.5 feet because it sits in the middle of the portal. So my result for 3.5 feet was an initial horizontal velocity of 5.14 feet per second. I was then able to find the initial horizontal velocities of the cube at 10.5 feet, 14 feet, which is 5.17 feet per second. The horizontal velocity of 17.5 feet, 21 feet, is 5.5 feet per second, and the horizontal velocity of 24.5 feet, 28 feet, is 5.14 feet per second. The horizontal velocities of the different height drops are just about constant, meaning that the force of gravity on the cube is directly transferred into the initial horizontal velocity, giving the projectile motion a 10 out of 10. With the realism grades added up, overall Portal earned a realism grade of 89%, which means that the claims of Portal being a very realistic game when it comes to gravity is indeed correct. Thank you for watching. This has been an ESVPN production. Have a good day.